Hey guys, welcome back to AlgoYogi. We are doing tree series and we only have 2 more problems to go, which are marked hard. So let's go to our second last problem, which is binary tree maximum path sum. Let's visit the problem on LeetCode and see the description. So a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. So that's pretty straightforward. So a node can only appear in the sequence at most once, and it doesn't have to pass through the root. So just like the diameter problem that we solved in the past, the diameter of the tree, and here it's the path sum, which doesn't have to pass through the root. Now, given the root of a binary tree, return the maximum path sum of any known empty path. So basically, if you see the first example here, if you say like these are all the positive values, but it can contain negative values, if you see here in the constraints, so we'll have to take care of that as well. And if you're seeing here, so 2, 1, 3, that's one path, and that the sum of all these values is 6. So this is pretty simple. But here, if you see, this is kind of tricky. So now you see 9, -10, that just does not make sense. We shouldn't pass even through here because we don't want to add any negative value. Choosing nothing, if all the nodes are empty, choosing nothing or returning 0, that's better than returning any negative value. That's returning 0 is more than returning any negative value. So since this is already -1, the sum is -1, then our path does not need to pass through here. So that's why we will basically prune it or leave it right there, because at every given point we would ask ourselves what is the path sum, and that will ask its left child and right child. Okay, so let's try to understand this problem. And here, as you can see, the answer is basically 42, and that's like 15 plus 20, that's 35, plus 7 is 42. Okay, let's understand the problem on Notepad and see why we wouldn't choose negative values. Well, I didn't have anything to say after that. Anyways, so if you see this, we already understood. It's easy to follow along because it's just one path. So and all values were positive, so we just included all of them, and the sum is 6. So that's all good. But now if you see here, what would be our path that we return in this one? So if you see, this is one path, and remember, it does not need to pass through the root. So this is also another path, right? This is another path. Now, what if you say, how about this? Is it a path? No, because one node can only appear once in this entire sequence of nodes we're collecting. So if you say, how about this? See, 3 is being basically repeated twice. If we are following this path, going over here and then following like that, that's not path. So now what we're going to do is, at every node value, we will ask if we will have like a result that we will basically initially we can say is 0, and then we can keep updating it at each node, but we will calculate that node's maximum path by asking its left and asking its right. So here it would be 0, 0, and this would have like a maximum path sum of 4. Then we will ask this node. I'm just randomly telling you guys, but this is how we're going to do it. So let me just take a cleaner approach and okay, so this is how we will do it. So we call our recursive function over here, and that will basically ask its left child and right child. And then let's start exploring. Like, let's say we're doing in order traversal. So we'll explore the left side, and this will ask its left and right, which will basically say we have nothing, 0. Then this will be like I have maximum path sum of 2. Then my result would become 2. All right, but then this will basically return 2 over here. How about it was negative 2? Then what? So I think that's where we need to take care of that we are never returning any negative value to the parent that basically called its children, you know. So if it was negative, we wouldn't return anything, but it's not, so let's just skip. Now it will ask its right child, and then this is not the leaf node, so it will ask its left and right. So these will basically, you know, following the previous example, previous node basically. So this will return 4, this will return 5. Now this has to take one of the maximum, but this also can decide for itself that I am the node that is splitting. That's the one where we split, rather than basically the path passing through the node's parent. Let the path pass through this current root. So 4 plus 3 plus 5, that will give us 5, 4, 9, 3, 12. So now we will update our answer to be 12. Remember this, the result was also updated here as well. So it became 4, then it became 5, now it became 12. But here this will also return 5. It wouldn't return 12, it would return 5, because you can't just take this path sum and return 12 to the parent. You have to return the maximum, so which is this path. So you basically returning the maximum sum path, a maximum sum of this path, whatever from that node, without splitting. So this will give 5, and 5 plus 7 plus 5 plus 1 plus 2 would be basically 8, and that's not going to update our answer, so answer would be 12. All right, so it's going to be, I think the approach is really similar to how we did the diameter problem. It's just like now we are adding the values rather than counting the number of nodes in that path, right? So we're just adding the values. All right, let's switch and code it. I said we will have like a global variable to have an updated answer. I'm gonna have like I'm making it a list so that it's accessible inside my DFS function, which is inner function. It's gonna take root as a parameter, and then if root is none, then we return 0, right? Initially it's also, I'm keeping it 0 so that, you know, in worst case we're not selecting anything and returning 0 rather than returning any negative value. All right, but then let's have left path sum, which will basically call the DFS on root.left, and same way we're gonna have right path sum that will call DFS on root.right. One more thing, here we wanna basically return maximum. Is it maximum? I think yes, not the capital case. Okay, uppercase, so not capital letter. So root.left or not this. So either we get some value, some positive value, maximum positive value from the left side, or we return 0 if it came negative, right? So we don't want to have like a negative value return, because I would rather choose nothing than, you know, choosing a negative value. So the same thing with the right side, and then we will update our answer. Now my result at 0th index would be maximum of this is not what I'm returning right now. I'm just updating my answer by adding root.value, so that this is where the split is happening. We will basically we're not returning this value to the parent where it was called before. Like these left side and right child, they must have been called by a parent. But what if we were getting some maximum value over here? So we will update, we will rather pass through that path than going back up. And that would be root value plus left sum. And remember, it could be 0 as well. Left sum and right sum. I have a bad habit of copying these variables. I don't know, just it's a habit. I think I should type them more. But anyway, but what now? Our answer is updated, but we will now return. Now root value will definitely be added because it has to pass through the root. But now out of left and right path sum, I will basically have maximum of these selected, right? Maximum of these selected, and if they were both coming negative, then I would return 0. Maximum of 0, 0 is 0, or negative 1, 0 would be 0, right? So I think that is it. We can now call DFS right here on our root and just return our result at 0th index. All right, so let me zoom out and run it on the examples, and I think it should be okay. It shouldn't be value. Yeah, this is one of the problems sometimes. All right, so that's good. Let's submit it. And I think we did have some issue, and there was result 0, maximum of root val left plus right, maximum of left and right path turning 0. When the root was just -1, then we are returning 0. Oh, okay. Yes, so I think we do want to choose at least one node. So I think it would be, we will just initially, we will assign this as root.val. So I think that would just, do the job. I think this is just, these are like edge cases that you basically ask your interviewer. I would, as I said, like I would rather choose like a null value, but they want us to choose, if it's just one root, then our path has to pass through that. But I was considering if a root has like both none nodes, like left side and right side subtrees or nodes, they have none values, then I would not return none, then choosing those. But anyway, all right, so let's write the time complexity. Time complexity would be big of n, that's the number of nodes we are visiting, and space complexity, it's a recursive function, so implicit space complexity that is being used as stack when you're calling recursive function. Worst case it could be n, but let's just safe side, let's call it h, which is the height of the tree, because it keeps calling those functions DFS of the stack when it's basically reaches their height and keeps calling them off and start putting more nodes. And maximum goes to maximum node it has on the stack, parent node by h. Okay, let's go back to AlgoYogi, mark this solved, and we have one more problem to go. All right, let's get it. Bye bye.